Welcome to Ready to Derive. In this video, we're going to learn about multiplying polynomials. In particular, we'll start with multiplying a monomial by a monomial. We'll learn about the distributive property and the area model as a way to help multiplying binomials. We'll also learn about the FOIL method for multiplying binomials, and then we'll end with the general case of a polynomial times a polynomial. If any of this terminology is unfamiliar, you might want to check out my previous video, which I will link in the description. But without further ado, let's begin. So let's begin by practicing multiplying a monomial times a monomial. So something like 3 times 2x, like this, we have to understand that the operation implied outside there is multiplication. So it's really 3 times 2x. In fact, what is 2x? That's just 2 times x. So we have 3 times 2 times x, which is just 6x. So it may seem like common sense, but let's sort of build it up a little. What if we had 3x times 2x? Now, we could also have parentheses around the 3x, but we don't need to. But you could put it there if it helps you to kind of break it up. So that would be 3 if we just, it's all multiplication. So if we just kind of rearrange it, we have 3 times 2, which is 6, and x times x is really x to the 1 times x to the 1, which is, we can write more conveniently as 6x squared. So let's do it a little differently here. So I think we're seeing that 3 times 2, we can do that straight away as 6. And now maybe I'll put an exponent. That x out there has an exponent of 1. And we realize that we can just add the exponents to rewrite that as x to the 6. Okay, so let's build it up a little more. So the same principles, 3 times 2 is 6. And we have the exponents of 2 and 5. So that is going to make x to the 7th. And what if we, now, no, if we have a negative out there, we don't need the parentheses, but I'm going to put it just to help us a little bit. Negative 3 times 2 is negative 6. X squared times x to the 5th is x to the 7th. So if we could sort of formalize this and think about what's going on here. If we have two monomials multiplied together, we realize that we can just take the coefficients, a times b, and multiply them, and then add the exponents to get the new power of x. So before we get into multiplying binomials and polynomials, etc., it's important to revisit the distributive property briefly. So unlike when we had before a times b times c, where it's all multiplication, you don't need to distribute, we do need to distribute when we have plus or minus in parentheses. So the first thing we have to do is distribute the a to the b, then the a to the c, and that gives us a times b plus a times c. So this should be familiar to everybody. But what's important here is to link it to an area model representation, because this is really going to help when we're multiplying polynomials. So if we take this rectangle, and let's say that the rectangle, the width of it is a, and the length is b plus c. Well, they're going to be different amounts. I'm just going to partition this here, and I'm just going to make this b and this c. So we see that the width is a, and the length is b plus c. Well, the nice thing about this is that if you wanted to find the area of this rectangle, you would just take the width a and multiply it by b plus c, which is the length. So this whole expression is just the area of the big rectangle. Alternatively, though, you could partition the rectangle and say, well, what's the area of this portion here? This would just be a times b. And what is the area of this partition here? Well, that would just be a times c. So a times c, which proves, or demonstrates, shall I say, the distributive property. So this area model is going to become very useful. So now we reviewed the distributive property. Let's just do a little practice. So here we have a monomial times a binomial, technically. Still the same principle applies. So we know that we have to distribute the 3 to the 2x. So that would be 3 times 2x, and then the 3 to the 5. Could have done that immediately written as 6x plus 15, but it's nice to see how it's broken down. And to use the area model, in case you would, you like this method, you would make the width 3, this 2x, this 5, and then you could say that the area of first rectangle would be 6x, that's 3 times 2x, and then the second would be 3 times 5 is 15, which checks. Now let's do a monomial times a polynomial. And some people just prefer to do it the area model, use the area model off from the get-go. So that would be 2x, x to the 4th. This would be 3x squared. Do not worry about this being minus 5x. It's purely a representation. So we would have 2x for the area of the first rectangle, 2x times x to the 4th, which would be 2x to the 5th, 2x times 3x squared, 6x cubed, 2x times negative 5x, negative 10x squared, and then 2x times 1, 2x, so that we know that this would expand to 2x to the 5th plus 6x cubed minus 10x squared plus 2x. So we will look at a case of a binomial times a binomial. If you think about it, we have two things that we have to distribute into the parentheses. Now we have like an x times 2x plus 5, and we also have that 3. So I'm going to write it like this to kind of help break it up for you. So we have x that has to be distributed into 2x plus 5 plus, and then we have the 3, just to be fair. So the 3 has to be distributed into the 2x plus 5. And then now we distribute the x into here. So we have 2x squared plus 5x. And then the 3 into the same parentheses, basically, plus 6x plus 15. And now we can actually combine some like terms. So we have 2x squared plus 11x plus 15. Now let's have a look at that using the area model. It's kind of neat to see this here. We when we did x times, let's see, if you think about it, if we just had a monomial times a binomial, we would have had this, 2x and 5. But we are actually adding on, see, we are adding on an extra dimension here. So we have 3 times 2x plus 5. So let's take the upper left-hand corner box. That would have an area of 2x squared. X times 5, that would have 5x. 3 times 2x is 6x, and then 3 times 5 would be 15. And what's nice about this method here is that you sort of, on the diagonals, you will find the terms that can be combined. So you would get 2x squared, 6x and 5x, 11x, and 3 times 5, 15. So we're going to look at multiplying a binomial by a binomial, one more method. It's called the FOIL method. We did this by double distributing and also by the area model, but this is pretty neat. So what does it all stand for? So what does the F stand for? F stands for the first terms, to multiply the first terms in each parenthesis. So that would be x times 2x. That's what F is. So that would give us 2x squared. And what does the O stand for? O is the outer terms. That means the outermost terms. So that would be the x times 5. So that's 5x. I is for inner, the innermost terms, the ones closest to each other. So that would be 6x. And L is for last. I guess I forgot to color code up here. Pardon me, there's the I is the orange, and L is for the last terms, and that would be the 3 times 5. So that would give 15. And of course, in between all of these is plus. So we have 2x squared plus 11x plus 15 one more time. And the nice thing about this is it's kind of got a symmetric feel to it, and it's very efficient, and actually particularly useful when you do eventually get into factoring. So we're just going to practice what we've learned so far. So we have, here's a monomial times a binomial, and we're just going to kind of, you can use the area model if you choose to, but I'm just going to do this algebraically. So 4x times 3x is 12x squared, and then 4x times minus 2 is negative 8x. Let's come to here. All right, so we're going to be distributing 4 times now. 3x squared times x cubed.
3x to the 5th. 3x squared times x squared is 3x to the 4th, plus 3x cubed minus 3x squared. All right, now let's get to binomial times binomial. Now, let's do it. We're going to do it using the FOIL method. So the first terms, 3x times 2x, is 6x squared. The outer terms is plus 3x, and the inner terms is minus 14x. The last is negative 7 times 1, which is minus 7. So we get 6x squared minus 11x minus 7. And just circle that. And here, let's do this again. So the first terms will give 9x to the 4th. The outer terms will give negative 30x squared. The inner terms, conveniently, give plus 30x squared. And the last terms will give minus 100. So these cancel, and we're left with 9x to the 4th minus 100. So the last thing we're going to learn in this video is how to multiply a polynomial times a polynomial. In fact, we're going to do just a trinomial times a trinomial because anything longer than that would just be tedious. We can't use FOIL in this method because we don't have two binomials. So we have to really just use repeated distribution. But let's do this systematically. So let's start with, we have to take that x squared and distribute that into here. So I am going to, let's see, sorry about that errant mark. Just trying to keep color coded. So x squared times that will be 4x to the 4th minus 2x cubed plus 5x squared. And now, to be fair, I'm going to take positive 3x and distribute in. And I won't, well, I guess I could just show those arrows. It's going to get very busy. But when I do 3x times 4x squared, I actually get a 12x cubed. And to be organized, I'm going to line this up vertically. So the 12x cubed will be my first term, so that it will be easy to combine like terms. And then we would get 3x times negative 2x, negative 6x squared, and 3x times 5, which would be plus 15x. And then we just have to do the minus 1. And I won't put any more arrows there, it'll get confusing. Minus 1 times 4x squared will be negative 4x squared plus 2x minus 5. By doing it this way, you can see it's very easy then to combine like terms. So 4x to the 4th has no like terms. 2x cubed and 12x cubed will make plus 10x cubed. The x squared terms will all combine to make minus 5x squared, 15x and 2x, 17x, and then the minus 5. So that's one method to go about it. You could also use the area model, and there's no reason not to make everything the same length. That you can do that, that's just fine. So we're going to put, let's have x squared. This is just symbolic, so it doesn't matter if it's they're all the same size. That's 3x, and that's minus 1. And I'm going to put up here, let's see, we'll put 4x squared minus 2x, and this is plus 5. And then we'll just multiply throughout. So x squared times 4x squared is 4x to the 4th minus 2x cubed, 5x squared. So 3x times 4x squared, 12x cubed, minus 6x squared, 15x, and finally negative 4x squared plus 2x minus 5. The nice thing about this method is you combine like terms on the diagonal. So 4x to the 4th stands alone, but these two, the x cubed terms are on a diagonal, and the x squared terms are on a diagonal, and we'll simplify to negative 5x squared, 15x plus 2x, 17x, and then the minus 5. So for our last practice problem, we are asked to expand the following, 2x minus 1 cubed. And what you don't want to do, very dangerous thing, this is not equal to 2x cubed. You cannot so-called distribute the cube, okay? And when I write this out, you'll understand why. Because 2x minus 1 cubed is 2x minus 1 times 2x minus 1 times 2x minus 1. Now that's 3 binomials. We cannot multiply 3 things all at once at the same time. We have to pick 2 things to work with and then go from there. So I will just carry down this 2x minus 1 here. And then we're going to multiply 2x minus 1 times 2x minus 1. So we're going to do the first term. So I'll just stick to one color here. So that's 4x squared. The outer terms is minus 2x. The inner terms is minus 2x. And the last terms gives plus 1. So then we are at 2x minus 1, and if we simplify this before multiplying again, we get 4x squared minus 4x plus 1. Now, in doing the next step, you could use the area model, you can, whichever method I've taught so far, but we're going to just change it up a little bit again, and we're going to, let's write it out. 2x times 4x squared minus 4x plus 1. So I'm kind of writing this horizontally instead of doing the vertical method we did moments before, which you do whichever whichever you prefer. And we have minus 1 times the same thing, 4x squared minus 4x plus 1. So we have a lot of distributing going on here. And that would give, let's see, 8x cubed minus 8x squared plus 2x after we distribute in the 2x to everything. And the minus 1 being distributed in would give minus 4x squared plus 4x minus 1. And then when we combine like terms, we'd get 8x cubed minus 12x squared plus 6x minus 1 for our final answer.
Thank you for sticking around to the end of this video. If you enjoyed the video, well, enjoy might be a stretch. How about if you found it useful? Please do check out other videos on my channel, Ready to Derive. And if you were to subscribe, I would be eternally grateful.